All right, 3B, absolute value equation. So let's go ahead and start by getting this bit there by itself. Get the absolute value stuff by itself. So negative 2x, that's an abs, negative 2x plus 3, close the abs, equals 1/2 x plus 6. I've added that 5 to both sides. Now that I have the abs by itself, I'm going to split it into two equations. One equation will be negative 2x plus 3 equals 1/2 x plus 6. The same exact thing. My other equation is going to be negative 2x plus 3 equals negative 1/2 x minus 6. The opposite of the left side. It's literally what I started with, 1/2 x plus 6, but the exact opposite of it. You will always, always, always do that when you're dealing with an absolute value equation like this. Let's solve the positive equation first. I'm just going to multiply everything by 2 to get rid of that 1/2. Why not? Negative 4x plus 6 equals x plus 12. Subtract x from both sides? I don't know, why not? Negative 5x. Let's subtract that 6 as well. Equals 12 minus 6 is 6. So x equals negative 6 over 5, maybe. And now let's take a look at our red equation. Red equation, let's do the same thing though. Let's multiply everything by 2. So negative 4x plus 6 equals negative x minus 12. Now let's add x both sides. It doesn't matter how you do it. So we're going to get negative 3x, subtract that 6 equals negative 12 minus 6 is negative 18. Divide by negative 3 to get x equals 6. Maybe. What are you doing, Mr. Reed? Why are you saying maybe? Well, when you're dealing with an absolute value equation, you sometimes get extraneous solutions, which means you're getting a solution to a derived equation that is not a solution to the original absolute value equation. It's coming from the fact that the absolute value operation is not an invertible function. What on earth am I talking about? Whatever, let's just do it. What does it mean? Well, it means we need to check. So take the original expression, this absolute value of negative 2x plus 3 minus 5 equals 1/2 x plus 1, and plug in both values and see if you get a true statement. So with the negative 6/5, let's plug it in. Absolute value of negative 2 times negative 6/5 plus 3, close them, equals 1/2 x plus 6. Notice what I did. Let's go ahead and simplify this absolute value nonsense. Negative 2 times negative 6 is positive 12. So I have 12/5 plus 15/5. Notice I totally just got a common denominator, so I can add those. Equals, let's just leave that 1/2. Oh, I forgot to plug in my x value, which was negative 6/5 right there, plus 6. Keep going. 12/15 plus 15/15 is what? 27/5. I said 15ths. I meant to say fifths. 27/5 equals 1/2 times negative 6/5 is going to be negative 6/10 plus 6 with a denominator of 10 is going to be 60/10. Gross. Simplify that right hand side. Negative 6 plus 60 is going to be 54 over 10. Is 54 over 10 the same as 27 over 5? Yeah, 54 divided by 2 is 27. 10 divided by 2 is 5. Therefore, they're the same. Therefore, negative 6/5 is a solution. What about 6? Is 6 a solution? Well, do the same thing. Plug it in and see. Absolute value, negative 2 times 6 plus 3, absolute value, equals 1/2 6 plus 6. Okay, what happens? We get negative 12 plus 3 abs equals 1/2 times 6 is 3 plus 6. Negative 12 plus 3 is negative 9 right there equals positive 9, but that's an abs, so 9 equals 9, so yay, 6 is also solution. So this had two solutions, negative 6/5 and 6. If you do not check, you will not get full credit, because you have to check, otherwise you just don't know.